Okay guys, welcome to the new video lecture series of CNC machine. In this lecture, we will talk about the writing a part program. Okay, after we have done the what is the thing needed to the program, and now we will know how to write a program. There is also a method or a way of writing a program. Okay, let's without much delay, let's start our lecture. The first instruction in any part programming is to inform the control system about various set of condition for the machining tasks to be taken up. Before doing anything, we have to do some preparation. Okay, we have to say the job workpiece is at this position and you have to go there. Before that, we have to give some feed for revolution. What is the absolute or coordinate system, absolute or incremental coordinate system, what is the feet per per minute or feet per minute. Okay, these things. Okay, as words, t words, f words, this type of words. Okay, now the many part program start in a similar way. The first program should specify the following: block number and numbers, coordinate values, absolute or incremental. We will give the coordinate system by G90, absolute coordinate system, and G91 incremental incremental coordinate system according to our requirement. Tool number if possible, that is T words. Spindle speed S words, and feed function, that is feed function per minute or other. Okay, G94 and G95. The first block of a program will look the first block of the program will look like this is n numbers. Okay, sequence number, and this is G90 absolute coordinate system, G70 metric system, G94 per feed rate type. Feed rate not in 200 per minute, not feed rate unit, what type of unit, per minute or maybe. And M03 spindle start as spindle revolution at 800 rpm, end of block. Let's go to the technique. What is okay? I hope you are guys seeing the okay. Now machining in a point to point. Okay, point to point, and one is point to point and another one is machining along a straight line. Okay guys, these are the technique. In a point to point CNC system, workpiece or the cutting tool moves one point to another point and machining is done at a specific point. As its name suggests that the machining is done, if I have to do here and here, then what we will do, I will just program in a machine that first go to here and just drill it, and then just come above the surface and then go to this place and just drill here. Okay, like this way we can say the program or a CNC machine. Okay, we have to instruct the machine. So in a point-to-point CNC machine system workpiece or the cutting tool moves from one point to other point and machining is done at a specific point, and no machining is done when the spindle or workpiece is moving between the 2 points. I already saw that from whenever I am moving from one to here, I have to come above the surface, do not touch to the surface and go to here. Okay, like this. To illustrate the point to point machining, let us consider the following figure. Okay, first of all, we will know the geometry, what we want to need and where we want to drill it. Okay, here it is an 60 by 40 workpiece where I have to make the 3 holes. The 3 holes location is at this is 10 above and this is also 10 above. Okay, this point is 10. Okay guys, this point is out. At what point I have to do at x distance at 50 and y at a 10. Okay, and in this point I have to move both y point where 50. Okay, first of all we have to write x coordinate. Okay, don't do this type of mistakes, silly mistakes. Okay, now this is 20 from this position to this position, and the distance from here to here is, you will know from here, this is 10. Okay guys, 10, 20 plus 10, this we will get this the center point of this point. Okay, what 20 plus 10, 30, and how much above from the y? we are in a, okay, sorry, this is x direction, so it is 50. And how much above we are, above from the x in a y direction, how much we, 20 plus 10, okay, 50 comma 30. Okay guys, now let's we figure out the where we want to machine, where we want to machine, or where we want to drill. Okay, now depth of hole is 10 mm, we will assuming that, and z0 at the surface of the workpiece. If we make z0, it will touch the surface. Okay, 0 at the surface. The cutting tool is position above the surface. Now assuming at a z0 the tool will touch the workpiece, but now we are assuming that my tool is above, this is 0 and above 0. Okay, this is above 0. Okay, this is my tool. Okay, I will show that this is my love, this is my workpiece. This is when it touch the workpiece, it is 0, and my workpiece is now at a certain distance above from the workpiece. Okay, now let's start. And 10, this is, okay, and 10, okay, you will know guys, don't worry. And 10 sequence number, G71 metric units, G90 absolute coordinate system, G94 I had written it in a very sequence manner so that you guys can memorize it. G71 metric units, G90 absolute coordinate system, G94 units of cutting units, feed rate units, okay, mm per minute or other, and end of block. And in second, we will provide miscellaneous code, that is spindle start F200, feed rate 200, as spindle revolution 1000 revolution per minute, end of block. And then let's go to the rapid transfer, G00 rapid transfer to X0 Y0. Okay, we will go X0 Y0. Okay, now we already assume that my surface is here, Z direction at this distance, and then go to the X0 Y0 like this way it will go. And then now I will give the computer, give the program G01 linear interpolation Z2 from the surface of the workpiece, just go above 2 mm above, okay, end up, and then now start minus 10 means this is the 2, and from this 0 and minus 10 it will go 12 mm, this 10 and this 2, because it is going to negative direction. Is this minus means negative, this is my z direction, then it will go 10 mm minus 10 till minus 10 mm. Okay, then after doing this, what we already told that the depth of the hole is 10 mm. Okay, the desired depth of hole is 10 mm, so it will go to the minus 10 mm depth. And then rapid transfers G2 means, okay, come to the above, to the 2 mm above from the work surface. Okay, now what we will do, it will just hold this surface, make the hole at this position. Now come to the above 2 mm and go. Now we have to say go this position and just do the same work, and then come and then go. Okay, now you may have understand what I want to tell you guys. Okay, now Z2 G00, okay, G00 Z2 end of block. Okay, now G0 rapid transfers X, okay, this is 50 guys, sorry, this is 50. Okay, rapid transfers, go to this 50 position. Okay, this is X is already X, we made Y equal to 10 already, so this will run until we will not change the Y coordinate. Okay, go to 50 and just G01 linear interpolation Z minus 10. Oh, okay, make a drill of 10 mm. Okay, it will make it. And G00 Z2, okay, come after doing this hole, come to the 2 mm above from the surface. Okay, G00 Y30, go to the 30 in a Y direction. Now we change the Y. Okay guys, because now 50 is same, 50 is already given here. Now we have to change the Y coordinate. Now go to the Y, 50 comma 30. Okay, G01 Z, same work, go drill, end of block. Okay, now G02 after completing, we don't need to do any drilling works. And just come to the point Z20 x0 y0 x0 y0 at a 20 mm above. Okay, end of block. And 130 m02 program stop. Okay, what will m02 will do? Program stop will do by m05, guys. Oh, end of program. Okay, end of program. Okay, sorry. Okay, now in next lecture we will talk about what is dual and machining along straight line, and another one is another. We will talk about subroutine. What is subroutine, and what is can cycle also. Okay, guys. Till now, thank you guys.